Hi everyone, today we will discuss types of functions. So let us start with this constant function. So if you consider the constant function, so here you can just see the definition. If the range of the function f consists of only one number, then f is called constant function. Like suppose here, if you consider suppose f of x is equal to some constant c. Now whatever be the value of this f of x, whatever be the value of x, the value of f of x, it will remain same, and that is equal to c. So that is the meaning of this. The range of the function means the value of this f of x or value of y. So that will remain same throughout, because here whatever value of this x, this c remains same. So yani f of x is always constant, f of x is equal to c for any value of x. So it means range of the function remains same. The domain is changing, but the range of the function remains same as far as the constant function is concerned. So such type of functions where the domain is variable but range of the function remains same is termed as constant function. Similarly, you can see this polynomial function of degree n. So if you take any function f of x, and if it starts with the power, suppose x to the power n. So here we have a naught x to the power n plus a1 x power n minus 1, a2 x power n minus 2. You can see this n minus 1, n minus 2, n minus 3 dot up to n minus n, that becomes 0, x to the power n minus n, that will be x power 0, that is 1. So finally we have this constant here, that is an. So in this polynomial of degree n, and see f of x equal to a naught x to the power n. Here a naught is termed as the coefficient of x to the power n. A1 will be termed as coefficient of x power n minus 1. A2 it is again coefficient of x power n minus 2, and so on. And similarly the last term here an, it is the coefficient of x to the power n minus n, but x to the power n minus 1, that gets hidden there because n minus n it is 0, x power 0, that is 1, so it is not appearing here. So it becomes, or it gets converted into a constant. So now an you can say a constant. Here a naught, a1, a2, that is also constant, but once a constant is with the variable, then that constant is termed as coefficient of that variable. So here a naught is a constant, but it is with this x to the power n. X to the power n is a variable, so we can also say a naught is the coefficient of x to the power n. A1 is the coefficient of x power n minus 1, A2 is the coefficient of x power n minus 2, and so on. So this is the polynomial of degree n. This now here n is non-negative, means it should be a positive number, and a0, a1, a2, they are all constants. They are constants, but they are also termed as coefficients once they are with the variables. Here a naught is not equal to 0 because this first term here, a naught is the coefficient of x power n, it should not be 0 because once it is 0, then this term will get eliminated. So we say that this a naught, it should not be equal to 0. Then this f is called polynomial function of degree n. So here if you just want to write such type of relation, suppose you have f of x is equal to ax square plus twice of bx plus this c. This is a quadratic expression, ax square, power here it is 2. It is the highest power it is 2, then it is 1, then it is 0. So it is a quadratic expression. Similarly you can write f of x equal to ax cube plus bx square plus cx plus d. This is a cubic expression or cubic function. And similarly we can have nth order function. So nth order function, if you write f of x is equal to a naught x to the power n plus a1 x power n minus 1 plus a2 x power n minus 2 dot an x to the power n minus n. Okay, and an x to the power n minus n, that will be only an because x power n minus n, x power 0, that is equal to 1. So this way you can always form the expression as far as the polynomial of any degree is concerned, polynomial of any degree, whether it is n minus 1, n minus 2, 2, 3, 4, something like that. If you consider y is equal to ax plus b. So this is a linear function because the maximum power here it is 1. So it is linear, this is quadratic, this is cubic, and this is for nth order. Now if you consider this rational function, a rational function, all of you are aware of this. We have this, suppose a function f of x equal to px upon qx. Px, that is also a function of x in the numerator, and qx is also a function of x in the denominator. So if f of x is in the form of px upon qx, where px and qx are two polynomial functions, and obviously qx is not in the denominator, so it should not be equal to 0. So qx is not equal to 0, then this f, and this function is called a rational function. So just to summarize, f of x equal to px upon qx. Px is a polynomial and qx is also a polynomial function, but the denominator it should not be 0 in general, and that's why qx it is not equal to 0. Then f of x is called a rational function. Now we have another function called odd and even function. So odd and even function, it depends on this value. If you have a function f of x, and if you change the sign of the x, sign of x, like if f of minus x equal to minus of f of x, when sign of this domain changes and corresponding to that the sign of the function, sign of the value of the function f of x also changes, it means it becomes a case of what? Odd function. And if f of minus x is equal to minus of f of x, f of minus x equal to minus of f of x, domain sign changes, corresponding to that the value of sign of the value of the function also changes, it means it is an odd function. Corresponding to that you have, if f of minus x equal to f of x, change the sign of the domain, but there is no change or there is no effect as far as the value of the function is concerned, then in that case that is termed as the even function. So if f of minus x equal to f of x, then that is a case of even function. If f of minus x equal to minus of f of x, this statement you can also use like this: f of minus x plus f of x, that will be equal to how much? 0, because f of minus x is equal to how much? Minus of f of x. So this becomes minus of f of x plus f of x. If it is equal to 0, it means in that case f of minus x is equal to how much? Minus of f of x. So if it is 0, so f of minus x plus f of x equal to 0, it means that is condition for odd function. So either you can see this way or we can narrate it in this way. So this is the condition for your odd function, and if they remain same, then that remains the even function. Now here you can see this assumption. If here the assumption is minus x belongs to domain of f of x, where x belongs to domain x and minus x, and that is obvious because whenever we discuss any function, okay, or the entire calculus you can say, we discuss under the domain, we don't go anything beyond the domain, because all the operations, all the rule or all regulation, that is based on whether we are out of domain or within the domain. So it means if we are within the domain, then only we can have all operations, whether it is algebraic operation, whether it is limiting value operations or any other operation, differentiation, integration, everything happens within the domain of the function. So here it is assumed that minus x as well as this x is part of the domain of the function, and then only we can have these conditions. Now you can see this periodic function. So if you consider the periodic function is nothing but we can define in a very simple way a period which repeats itself at a regular interval of time, that is termed as the periodic function. That is the general definition you can say. Any function which repeats itself at a regular, so like suppose simple pendulum, the time period gets repeated, the pendulum is repeating its oscillation at a particular time interval, and that period we call it at the time period of the simple pendulum. So similar is the periodic function. If a function repeats itself at a regular interval, then that function will be termed as the periodic function. Now numerically or analytically it can be represented as if f of x plus p is equal to f of x, means suppose we have a function f of x, okay, and you calculate its value at some domain x plus p, means f of x plus p. If f of x plus p is equal to f of x, then it will be a periodic function, and in that case this p becomes a period. P is a positive quantity, and that p will be treated as the period of the function. So if f of x plus p is equal to f of x, where p is the smallest positive real number, it's a small quantity but it is positive in nature, then this f is termed as the periodic function. For period we use the letter p, or sometimes we also use it as t. T means the time period, p means just the period. So here also you can say f of x is equal to f of x plus t. So here if f of x equal to f of x plus t, then t is the period. This can also be considered as f of x plus 2t, because again period t plus t, again t plus t plus t, and so on. So if all these are same, like if you consider the simple pendulum, okay, so oscillation of this, it will be moving like this. So it comes from this point to this point in time t, again comes back and comes here. So from here if you measure, this time interval is how much? 2t. From this point it becomes 2t, but from this point it remains same as this t. So from this point to this point it comes in t, again from this point to this point it comes in time. If you change the reference point, then the period will remain same as t, but the time duration between the reference points, that will change. With this reference point here it is t, here also it is t, but with this reference point here it becomes 2t, and here also it becomes 2t. So that way also we can analyze, because function is repeating itself at a regular time interval, the function is repeating itself. So we can say it is repeating after t, or we can say it is repeating after 2t, it is repeating after 3t. So depending on the reference point that we choose, so accordingly we can always analyze these periodic function or any periodic time or any periodic event in general like this. So we have f of x equal to f of x plus t is equal to f of x plus 2t, and so on. So that way also you can analyze. Now here if you consider a particular problem, so if you consider fraction of x, if you recall your greatest integral function, so suppose there is a number x, corresponding to that the integral part is this x, integral of x. So fractional part, it will be how much? Fractional part is x, that is equal to x minus this integral of x. If you consider this 2.5, this number, so 2.5 is your x. Integral of this 2.5 will be what? 2. So 2.5 minus this 2, and that is equal to 0.5. So here this represents your 0.5, this represents 2.5, and this represents its integral value, and that is equal to 2. So this is just the general form of all this representation. So we have this fraction part which is equal to x minus its integral part, and this function, it is periodic with the period 1, periodic with the, it is just repeating, because you can see 2.5, 3.7, 4.9, it will be how much? Its integral part is 2, its integral part is 3, its integral part is 4. So 2, 3, 4. It means here it is just repeating after a period of 1 between the two consecutive integers. Between two consecutive integers, what is the gap? That gap is 1. So it is repeating itself at an interval of 1. So that's why we say that the period of this function or this expression, it is 1. So this you can see like this. you can see this here. This is your 0 here, this is 1, and this line is at a, this is suppose your x-axis. So this line is drawn at an interval of 1, at a distance of this 1. So this is 0, 1, this is also how much? 1, 1, this will be, this coordinate is 2, but this remains same as 1, so 2, 1. So here it is just repeating between two consecutive integers, it is just repeating, this one is repeating itself. So that's why we say the period of fractional x is equal to x minus integral x, it is equal to 1, because it is just repeating at an interval of 1. Because here, as far as the integral function is concerned, as we have just seen, 2.5, 3.7, 4.9, so these are the consecutive integers, 2, 3, 4, 5, something like that. So that is consecutive integer. Between consecutive integers, it is just repeating at an interval of 1. So that's why we say that the period is 1. Now here if you see this, if you have a function, okay, suppose you have a function f of x and its period is, let us say, p. Period of this function is p, and you have another function f of ax plus b. Okay, the domain here it is x, the function is now f of ax plus b, a is constant, b is constant. Then period of function f of x, if it is p, then period of the function f of ax plus b, it will be p by a. It is independent of this constant addition, this plus b, but here a is the coefficient of x, so it depends on this coefficient. So period of the function f of x is p, so period of the function f of ax plus b, it will be p divided by the coefficient of x here, and that is a, so it is p by a. So that way you can calculate it. Now here there are certain properties, and you should keep in mind these properties so that the calculation part becomes easier. When you start solving some problems, then calculation part becomes easier if you have these things in your mind. Period of sin x see this here, period of sin x or cos x, it is 2 pi, period of tan x, it is pi. Now from that let us generalize. Period of sin to the power nx, cos to the power nx, sec to the power nx, cosec to the power nx are periodic functions with the period 2 pi and pi, where n is odd or even. If suppose let us say n is odd, so n is odd, so sin to the power nx, n is equal to let us say 1, so that is sin x. Cos to the power nx, that is suppose n is 1, so cos x. Sec x, cosec x, it means in that case sin x, cos x, when I am taking n is equal to 1, so period of sin x, you know, it is 2 pi, period of cos x is 2 pi, period of sec x is 2 pi, period of cosec x is also 2 pi. This clear? So corresponding to that, now n is equal to 3. Here n is odd, depending on that. So if n is odd, period is 2 pi. So now if you consider n is equal to 3, so still the period it will be 2 pi. If it is suppose n is equal to 5, period of sin to the power 5x, it is also 2 pi, cos to the power 5x, it is 2 pi, and so on. But if n is even, suppose sin square x, cos square x, sec square x, or sin to the power 4x, cos to the power 4x, sec to the power 4x, in that case the period changes and it becomes pi, means 2 pi divided by 2, so that becomes pi. So sin x, cos x, sec x, cosec x to the power n for every term, period is 2 pi provided n is odd, period is pi provided n is even. So this, if you can keep in mind, it will help you in simplifying problem. Otherwise you will again have lots of calculation and finally you will have come to the same conclusion. Now tan x and cot x. So tan to the power nx, cot to the power nx. Period is pi, whether it is even or odd. N is even or n is odd. It means period of tan x is same as period of tan square x, same as period of tan cube x, and that is equal to pi. Now let us come to the mod of sin x. When we simplify the problem, all these terms will get involved. Mod of the trigonometrical functions, power of the trigonometrical function, and then when we explain all the solutions of each and every equation, we will come back to all these concepts, how these periods changes, how these things are calculated, and that will give you more understanding. So mod of sin x, mod of cos x, mod of tan x, mod of cot x, it means mod of trigonometrical functions. For all these trigonometrical, whether it is tan, cot, sec, cosec, sine or cos, period of all mod trigonometrical function, it is pi. It is pi. Sine, cos, sec, cosec, we have two different, 2 pi and pi, depending on whether n is odd or even. Tan, cot, it is same whether it is even or odd, and that is equal to pi. Again, mod of sin x, mod of cos x, tan x, all periods are same for all trigonometrical function, and that is again pi. It means only difference is here, otherwise here also it is pi, here also it is pi. So just to keep it in your mind, you can keep this only for sine and cos. Sec is nothing but reciprocal of cos, cosec is nothing but the reciprocal of sine. Here only we have two different conditions, otherwise for any other trigonometrical function, whether it is in the general form or in the mod form, period it is pi. Now again you can see some of more expression. Mod of sin x plus mod of cos x, period it is pi by 2. Mod of tan x plus cot x, tan is always with cot, so mod of tan x plus mod of cos x. Sec x plus mod of sec x plus mod of cosec x, that is again pi by 2. So mod of sin x plus mod of cos x, it is pi by 2. Mod of tan x plus mod of cot x, it is also pi by 2. Mod of sec x plus mod of cos x, it is also pi by 2. So these are the periods of such combination of the trigonometrical function if they are under mod sign. This we have already discussed, that period of f of x, if it is t, period of f of ax plus b, it will be t upon. Now here again you can see this mod of a. So obviously we are interested only in the positive part of this a, we don't have to consider the negative part of that. So it is t upon, if it is suppose minus of 5x, then you will simply consider 5 here, t by 5, not t by minus 5. So that way we can discuss. Now suppose you have a combination of function, or you can say composite function, is this clear, or a combination of function. Suppose we have the function f of x, where f of x equal to a times this small f of x plus minus b times small gx plus minus c times small hx. Okay, so f of x is the combination of the function f of x, gx, hx and so on, and these functions are periodic with periods t1, t2, t3. f of x, gx and hx, their periods are t1, t2, t3. Then the period of the function, this f of x, it will be equal to LCM of t1, t2, t3. If it is not an even function, if this f of x, the outcome of all this, we are having this as f of x. If f of x is not an even function, then the period of this f of x, it will be LCM of this t1, t2, t3, and t1, t2, t3 are the periods of these individual functions. And if it is even function, then it will be half of LCM of t1, t2, t3. Calculate the LCM of t1, t2, half of that becomes the period of this function f of x. Okay, now sometimes how to calculate the LCM if it is in the numerator and denominator form. So if suppose you have terms like a upon a1, b upon b1, c upon c1, this clear, then the LCM of a upon a1, b upon b1, c upon c1 is calculated as LCM of all the terms in the numerator divided by HCF of terms in the denominator. So in denominator you have a1, b1, c1, and in numerator you have a, b, c. So LCM of a, b, c divided by HCF of a1, b1, c, LCM of terms in the numerator divided by HCF of terms in the denominator. So these are the various ways to calculate the period of the functions. Some of the things if you can keep in mind, that will be better once you start simplifying the questions, and even if you can't keep those things in mind, we will discuss different ways or different methods to calculate the period of any type of functions. So we will discuss how to solve problems, how to calculate the period of the function, how to distinguish whether it is an odd function or even function in the next video. Thank you.